All right, so we're back and we are doing 7.9, number 12 in this video. And the directions are for you to solve the following trig equations. Write your answer in the form of theta plus 2 pi k, where 2 pi represents an interval of successive solutions and k is any integer. So sometimes the next solution can be described as plus or minus pi k or some other interval instead of 2 pi k. So they just want you to find all solutions. So finding all the solutions is very different than finding, what we just did in that last video, which is we found it only for the first rotation. Okay. So when you're solving, it's really important when you're solving all equations that you're thinking about, going around in a circle and hitting that same angle over and over again. And you're trying to hit all of those. So I'll go through my tactics on solving these. If you remember from any of our other videos, here's my tactics or my tools for solving. It's basically use SADMAP to isolate the trig function. Once it's isolated, you can use trig function or 30, 60, 90 if you recognize it. If you're stuck there and you can't do those things, then I would factor. If you can't factor, then I would use identities. These are not in any particular order, but this is the way I tend to think about things. So hopefully this order and tool list can kind of give you a place to start. So here's number 12. And it says 2 sine squared 2x equals 1. So the very first thing that I notice is, again, my first tool is to SADMAP it. And I will SADMAP this. I don't need to factor it. And some of you are saying, oh, but Michonton has a sine squared. Yeah, but it doesn't have another separate term. Like say, look at number 11. Number 11 would definitely be a factoring one because you got sine squared and you got sine. So for number 12, we don't have sine squared and sine. We just have sine squared. So this is definitely going to be a SADMAP. And the way SADMAP works, because it's, probably your most comfortable tool because you've been using it for so long, literally since probably 6th grade. We call it SADMAP because it's PEMDAS backwards. And that's the order in which you would use to solve. Please think about sine, the function, being here in parentheses, just so that you understand how it all works, right? So the first thing I'm going to look for is subtraction or addition. And I don't see any subtraction or addition, so I'm going to move on. Then I'm looking for division and multiplication. Now, some of you are thinking, well, Ms. Johnson, there's this 2 and there's this 2. Which one do we do? Well, because technically this one right here is in parentheses, I'm not touching him because number 1, he's in parentheses, and number 2, he's inside a sign. And we just talked about how sign is listed under parentheses. Okay, so the first thing I'm going to do is I'm going to divide both sides by 2. This divided by 2 does not get rid of the 2 inside the parentheses. It divides out in front because 2 of something, 2 sines divided by 2 gives me 1 sine. Does that make sense? So 2 sine squared 2x divided by 2 just divides out. So then I get sine squared 2x equals to 1/2. Okay. So then I'm done with division and multiplication, and then I'm looking for exponents, and you're like, yes, you have an exponent right there, Ms. Johnson, the squared. Very good. How do you get rid of square root? Oh, I just said the answer. How do you get rid of squared? And you say, oh, square root. Very good. Don't forget the what. What should you not forget right now? Very good. The plus or minus. So here I'm going to put a big O plus or minus here. Ms. Johnson, where does the plus or minus come from? Again, this is where your calculator does not give you solution. Unless you look at the graph, it'll show you the both solutions. But when you put in the square root of 1 over 2, it gives you one answer. It gives you the positive version of it. So you, as the mathematician, need to remember that whenever you square something, the thing that can go inside is either positive or negative, and the output will be positive, right? That makes sense. So, all right. So enough of that. So just don't forget, whenever you take the square root, whenever you choose to take the square root to solve in an equation, you also have to remember plus or minus. Okay. And I'll show you how to check this using the graphing calculator just to verify your answer. Okay, so at this point right here, this is where I like to draw my picture. So here's my picture. And it says opposite over hypotenuse is 1 over root 2. So this is 1 and this is root 2. And it could be positive or negative. So basically, I'm going to ask, hey, where is sine either positive or negative? And you're like, everywhere. Oh, sorry. I did square root the numerator, but what's the square root of 1? Good question. I did square root the top, but it's just square root of 1, right? Is that okay? Okay, good. So you'll see me draw all 4 of them, and it looks like a bow tie to me. So notice here we got 1 over root 2, we got 1 over, or actually negative 1 over root 2, negative 1. So remember that your hypotenuse can never ever be negative because it's not a directional, right? The reason why those ones are negative is because you go down, and down means negative, right? So directionally, you can go negative in the left direction or down direction. But because that radical 2 represents the hypotenuse, which is the radius of a circle, we don't ever have a circle having a negative radius. Okay, so you should all recognize this triangle. You guys are like, oh my gosh, Ms. Johnson, this is the 45, 45, 90 triangle. I'm like, yes. So that means my angle is equal to pi over 4, right? That's this angle here. And then you have all these other angles here, here, and here that you also have to account for. So I'm just going to write those out. 2x equals 3 pi over 4. And if you don't remember why it's 3 pi over 4, just a quick little reminder. I'm cutting my pie or pizza up into slices of 4. If this is a whole pizza over here, and I take away a slice, that means I have 3 of the 4 slices. So same thing goes here, down here, this one right here. Now I have an extra slice of pizza, right? And the last one is I have 2 whole pizzas, and then someone took one away. So that's 2x equals to 7 pi over 4. Sorry, we're squeezing it in over there. And then they said earlier to make sure that you get all the solutions. And so the way I write my solutions is I put plus 2 pi, plus 2 pi, plus 2 pi, plus 2 pi. Now, the reason why I do that is because let's say I have this one angle right here at pi over 4. Now, I can get to pi over 4 just like that. Or I can go around a whole circle and hit pi over 4 like that. And you can imagine me doing that over and over again. That's why I not only want to go 2 pi, but I want to go 2 pi k. Okay, so k is any integer. And so if you looked at the directions, it said plus or minus 2 pi k. So if you want to put plus or minus 2 pi k, you can. But because they said that k is an integer, I'm adding 2 pi's, but I'm also subtracting 2 pi's. Does that make sense? I'm adding and subtracting by the fact that k could be positive or negative, right? All right. So the next step is we're just going to divide by 2 to every single piece. I go like this. And so one of them comes out to be pi over 8. If you take a fourth of a pizza, if you guys like really think about pizza, if you take a fourth and you take half of that, so you have a fourth of a pizza, and someone comes in and splits it in half, you now have an eighth of a pizza, hence pi over 8, right? So then plus pi k, right? And I'm just going to divide out the whole time. So this is going to be 3 pi over 8 plus pi k. And then I got 5 pi over 8 plus pi k. And then I got 7 pi over 8 plus pi k. So here's my answers. And that is correct. So some people, I will say, you can condense this even further if you don't want to write all of that out. Because if you graph these, right? So here's pi over 4, right? Here's my pi over 4s. Well, my pi over 8s are these guys in between here. Does that make sense? So you can condense this if you wanted to. And if you notice the pattern here, you're just adding 2 pi over 8. Do you see that? So instead of all of that, you can condense this into some very nice stuff by saying pi over 8 plus, and then you said that we were adding 2 pi over 8 k's. Does that make sense? So all of that condenses into that. Now, I'm just going to be honest with you. If you write all of this, are you going to be wrong? No, because all of those represent the same exact thing that this is. Now, if you're not in my class and you're watching this video, sometimes teachers want you to condense them into this nice little neat thing at the very bottom here. But just know and be confident that they're the same thing. Okay. So the way we got 2 pi over 8, just in case you're wondering, like, where the heck did this come from? Well, this was plus 2 pi over 8 gives you 3 pi over 8, right? And 3 pi over 8 plus 2 pi over 8 gave me 5 pi over 8. So I noticed that pattern. If you don't notice a pattern, don't worry about it. And just leave your answer alone. Okay, so what did we do? Let's reverse here. So the first thing that we did when we wrote it out, we thought, should we SAD map this? And this is a really good candidate for SAD mapping because it's a single trig function. There's not multiple ones like number 9 or number 11, right? And it has all this stuff attached to it. It has times by 2. It has a squared. And so when you're trying to SAD map, you're figuring out what's the order in which I should, take care of that multiply by 2 or the squared. Should I square root first? And actually, you could have, and you still would have gotten the same answer. But I just like to go in that order because that order makes sense to you because that's the order in which you simplify problems, right? So once we SAD mapped it and we got sine by itself, then we used the triangle graphed on the coordinate plane like this. You could have also used sine inverse of 1 over root 2, and it would have given you 45 degrees, which would have told you pi over 4, right? It's the same. But I prefer the draw your triangle. Recognize that it's a pi over 4 triangle kind of thing. And then I wrote all my answers out and I asked, where is sine, positive, and negative? And I'm like, oh, shoot, everywhere in every single quadrant. So that's why I wrote pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And because I wanted all solutions, then I added plus 2 pi k. So just think about me adding a bunch of circles over and over and over again, right? So then the next thing the next thing I did is I just solved. I got rid of the 2, just like you used to do back in 6th grade. We divide by 2 every single piece, and we got that answer. Now, if you're trying to push yourself to get the next level and you're trying to get this answer right here, you're just looking for the pattern between pi over 8 and 3 pi over 8. And then once you see how much you're adding, then you'll just add that like amount in. Okay. All right. Thank you for listening. And we're back because I forgot that I said that I was going to show you on the graphing calculator how to check this answer. So what you do basically is you take your graphing calculator and each side of the equation you're going to plug in. Okay, so I'm going to go from the very, very beginning of 2 sine, quiet alarm, 2 sine 2x, and I want to go back over here and put squared in. So 2 sine squared 2x, and then down here I'm going to put y equals 1. And then I'm going to look at where all of these answers are. So notice pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8. You can see that pattern, right? So now doesn't it make sense why it's pi over 8 plus 2 pi over 8? And then you're just adding sets of that over and over again. So that's how you basically check your answer. But I am going to be looking for all of this work because this is the valuable part. Okay, so that's how you would check your answer on a graphing calculator. I hope that makes sense to you. Now you can have a great day. Thank you.